Okay, so a couple things again to mention as we get started on the quiz preview. First, if you have misplaced, lost, never got your protractor, okay, there are more over in front of the folder if you need that, so get that out of the way. For those of you checking this out later, the following helps that are on the sideboard right now will be available for the quiz. Notice it didn't say maybe. Will be available for the quiz tomorrow. Okay, so again, that will come back up. For the time being, though, we're going to go ahead and jump into this quiz preview, which again is going to align very similarly to the quiz that you're going to be taking a peek at tomorrow. So, okay, we'll start with something that hopefully seems easy. Okay, drawing angles in standard position for each of the following lines. So, a couple things to remember. 40 degrees, okay, that seems pretty straightforward. I'm going to align, okay, my origin here with that circle that's in the bottom, because that way all the lines are lining up, can't even really tell that they're there. And I'm going to look on the inside of my protractor. The way that I always set it up, you'll end up on the inside, no matter which way we're going. You'll see over all three of them how this works. Okay? But again, also you can kind of use a little bit of common sense. Like for instance here, if I'm on a 40-degree angle, if I was looking at the inside, okay, that goes here. It's an acute angle. It makes kind of sense. If I was looking at the outside, it would be way over here. That's a really big angle. It's more than 40. So a lot of times you can just use a little bit of logic. But here's my 40. So again, we just kind of hover. Make our dot if it ever shows up. Thank you. And then we just connect with that dot. And remember, there is one other thing I have to pay attention to. I have to draw that arrow in to let the person looking at this know, is it a positive or a negative angle? So we go counterclockwise, always starting from my same initial side, which is the positive side of the x-axis. And get my arrow in, and that's all I need to do. But you've gotta get the arrow in there.
Does your line have to be exact? Because you can't really...
Yeah, as long as you're, that's a good question. As long as you are pretty close, yeah, I'm okay. If you're off by like 20 degrees, not so much. But like a couple, yeah, I give a little bit of wiggle room in there, sure. Absolutely. Okay, now B, it gets a little different.
Yeah, because there's only 185.
Yeah, so now what are we going to do? Okay, first reminder, when we're dealing with negatives, remember, we're going clockwise. So it would go something like this if I was looking at my main values. And I also got to remember, with that negative, that I'm going clockwise. So I start to look at this and I'm like, okay, so 90, 180, 185, well 185's not on here, this only goes to 180. How am I going to deal with this? Well, I can tell for sure that with my arrow, I'm going to get this far at least, because that would be 180, I know I need. How many more degrees do I need? 5. So what I'm going to do is I'm going to line this up, and I'm going to go find myself 5 more degrees. So I start looking, and I'm like, now, would it make sense if I went all the way around to here for 5? No, not really. So here, this time I'll use this guy. So here's my extra 5, right in between the 0 and the 10. What's that? Oh, it's going to. Because there's my extra 5. And when I get that attached in and finish it off, that'll get me set. Thank you. So here I now have my 90, 180, and my extra little 5 there to make my 185 degree angle. Okay, so I might have to kind of piece some of these angles together if they go over the 180.
So if it goes negative clockwise, positive counterclockwise.
Correct, and we'll even write that on this last one. Okay, so on C, when it's positive, we're going counterclockwise. So again, I look and I'm like, okay, so it goes here, here, bless you, here, and so on.
Bless you.
How do I know?
If it's negative, it goes like 0.
But how do you know what it's meant?
Okay, we're always starting on the positive x side. That's where my 0 is. No matter if it's positive or negative, I always start there. And here's how I tell people when they're like, well, how do I remember which direction to go with my numbers and how that works? Here's my best way of looking at it. When I'm doing counterclockwise, it's positive. If I start at the x-axis and I'm going up, I'm going into positive values. So I know that's where my positive 90 is. If I start at 0 and I go down, I'm heading into the negatives. And it just kind of helps me make that little bit of a connection with that. Sure. So once I get here, it's kind of like that last one. I'm like, okay, so if I start here, I know I'm going through 90, I know I'm going through 180, but I need some more angle. How much more angle do I need? If I'm at 180 and I need to get to 210,
So when you need 30 more.
I need 30 more. Now here's where it gets weird, so stay with me. Okay, notice I stopped at this point. My extra 30 I need is down here. So I'm going to take my protractor, I'm going to flip it over, and since I need 30 more, I'm going to go looking for my 30. Okay, there's my 30. Kind of hover here, make my dot. And again, like had been mentioned earlier, I'm not going to be like the, I better not say that with the way everybody's so PC. I'm not going to be such a stickler on it that it's like, no, yours is only 208 degrees wrong. I mean, if you're off 30 degrees, yeah, I'm going to mark it wrong. But otherwise, you know, as long as you're real close, we'll be okay. Okay? So that's how our measuring angles.
What if you're off?
Let's not. Yeah, two or three will be okay. I'll be able to eyeball it pretty well on something like that. So that's how the drawing angles would work. So then, for the next part, it says, find a positive and negative degree measure of an angle that is coterminal, which again will be on the help up front if you need it, which basically just means that you find another angle that's a full rotation, that's 360 degrees away. So you're going to find out on these, sometimes you're actually going to have some options. Because some people look at 445 and say, okay, bless you. So it says 360 more. So what if I do 445 plus 360, 805? Would that work? Sure. That's 360 degrees away. If I drew both those angles, they'd end at the same spot. But then when I go to do the negative one, it gets kind of interesting. Because if I minus 360, is that a negative angle? No. Now, I could write that if I wanted to. That also would be a positive coterminal angle. Still positive, it's still 360 degrees away. So either of those answers will work good for plus, but to get my negative one, I have to minus 360 again. So sometimes you may have to do it multiple times before you can get to that value. It just depends. So as we get to the next one, okay, negative 390. If I add 360, heading towards positive here, I'm like, oh, that's still negative. Okay. I'll just use that for my negative coterminal angle. It wasn't what I was trying to do, but got a bonus out of the deal. Let's add 360 again. Now it's positive. And I got both of them. I don't have to do any more. I don't have to go back and do the negative one again because I already have one. So not too bad of a deal. And then
Does that matter? Like, you don't have to have like 2 for the positive and 2 for the negative. You just need 1 for each.
one of each.
And if you get 2, then cool.
If you get 2, that's great. If you get the second one, you're like, oh, I got a second one. I really don't need to do anything with that. That's fine. I don't care. If you put 2, that's great. If you don't put 2, I don't care. And that time I had to do it once for each, and I got both of them. So nothing going too bad here as far as these go. But again, especially with the help, that shouldn't be a big deal. All right.
Oh, it's the coterminal.
Coterminal, uh-huh. So plus or minus 360. Okay, so as we flip over to the back, okay, notice, and this will be written the same way it is on the quiz, SOHCAHTOA. So your sine, cosine, tangent, they're all sitting there waiting for you. Okay, just didn't write them out completely. Okay, so show your setup and answer. So, I've got an angle to work with. Which two sides are the x and the 12? That's right. The hypotenuse, because it's across from the right angle. And the opposite, because it's opposite from the 25 side. So, opposite and hypotenuse go with sine. So the sine of 25 equals opposite over hypotenuse. And yes, it matters the order that you do it in. Because we talked about before, if the x is on top, you're going to multiply these two together. Okay, or I could just do it like an equation and multiply both sides by 12. That's fine. And I've said it a few times, and yes, my other class is starting to do radian stuff, so you have to be careful. Make sure you always check the mode on your calculator that it hasn't turned into radian. That's bad. Okay, so we're still in degree right now. And then I just type it in. 12 sine 25. Okay. And typically we're going to just go to the nearest tenth. If you went more than that, I'm not going to jump up and down and scream and yell. But 5.1 is fine. And I go about my business. So I look at the next one. I got my angle. Which two sides do I have this time? Hypotenuse and adjacent. So which trig function is that going to be? Okay, cosine. Cosine of 20 is 18 over x. If x is on the bottom, we're going to divide by our trig function. So it'll end up being 18 divided by the cosine of 20. And again, I could use my algebra to get there too if I don't remember that pattern. It's not a big deal. 19.2. And we're good there. And I just kind of keep working along with that. Okay, so on this next one, which sides have I got? I got opposite and adjacent. Which is which trig function? Tangent. Okay, tangent's opposite and adjacent. Opposite over adjacent. And again, x is on top, so we just multiply. So 41 tangent 62, 77.1. So then we hit up the last one. And of course I have to throw in a twist at the end, right? Never can keep this straight. So I look, I'm like, hey, wait a minute. Nice, okay. So which sides do I have? Opposite and
Never mind, I'm getting that.
okay, across from the right angle, so it's hypotenuse. Kind of is weird when I twist the triangle around that way. So opposite and hypotenuse, which trig function are we using? Sine. Yes, nicely played. Because second sine, that's why I put that little -1 there to remind me. Because when it's an angle, I do second in the trig function, and that little -1 comes up. That's why I wrote it. And then I go ahead and I put the fraction in. And again, here, if you went to the nearest tenth, if you went to the nearest whole degree, I'm fine with either of those. Not a big deal at all. So a little practice with our right triangle trig. And a little practice with our story problems. Okay. you got a building. It's going to cast a shadow of 70 meters. Now, we know all of these are going to be right triangles, so I'm just going to draw a right triangle to start with every one of them. So a building casts a shadow of 70 meters. Again, shadows occur on the ground. That's where you see them. You see them on the concrete. They're not just kind of hovering in front of you like a hologram or something. When the angle of elevation from the ground up is 50 degrees, how tall is the building? And now it's just like the problems we were doing up above. We just had to do a little calculating. So we have opposite and adjacent. So which trig function is that? Tangent. So the tangent of 50 equals opposite over adjacent. X is on top. We multiply. So let's see here. 70 times the tangent of 50. So about 83 point, oh, we're down to the nearest hundredth, excuse myself here. So a little over 83 meters. Sensible. Sensible. So let's see here. What else we got? We got another story problem. That's what we got. So now we've got, all right, right triangle. You lean a 20-foot ladder against a wall. So when I take the ladder and put it against the wall, it's kind of in an angle. So it lets me know that's going to be my 20. If the base is 6 feet from the wall, so hopefully some of you aren't touchy on the fact of everything being drawn to scale, because you're like, that's 20 and that's 6. Well, no, that's what you get for drawing the picture ahead of time. What angle does the ladder make with the ground? So it's a lot like what we did up in number 6. So I get here and I'm like, all right, let's see. Which sides we got this time? Okay, hypotenuse and adjacent. So what trig function is that? Cosine. And we're looking for an angle. Is adjacent over hypotenuse. So second cosine 6 divided by 20. Round to the nearest tenth, 72.5 degrees, and we're off and running. But again, just start with a right triangle. It's the easiest way to go as far as some of that stuff goes. All right. Over we go. Conversion time. Convert each of the following. Degrees to radian measure. Degrees to radians. We're going to multiply by pi over 180. Because we want pi in the answer now if we want it in radian. If you want to put the degree measure over 1, you could. The biggest thing to remember when we get to this, though, is going to be when you go to simplify it, don't include the pi in the calculator. Do the 190 over 180, little math enter here. But then I just put the pi back in to get my measurement. So keep it simple, keep it simple, keep it simple.
You're just simplifying.
Just simplifying, yeah, just simplifying the numeric part in front.
Just make sure you just put pi.
And then just make sure I slap the pi back in there. Yeah. That's basically all we've got to do on those. So just take the angle measure there, divide it by 180, simplify it down, and put a pi with it. Not bad, not bad, not bad. And then it's kind of the same concept when we go from radians to degrees, except now I want to get rid of the pi. So I multiply by 180 over pi. And again, that's up in the help. So even if you forgot a little bit, shouldn't be a bad thing. Okay. Pi should cancel. I just do 180 divided by 3. What's that? Okay. Cancel out the pi's. 2 times 180. And I just keep running with that pattern.
Wait, why did you multiply? I thought we were dividing.
Nope, we're always multiplying when we're doing from radian to degree or degree to radian. So 3 times 180 would be 540.
You divided the first one.
That's because we were changing to radian.
Okay, now I'm glad you mentioned that. Okay, it feels like you divided because I multiplied by the pi over 180. If I'd have just multiplied across here then, I'd have had 180 over 3, and I just reduced the fraction, or divided it. That would be the same thing to get me to that. But I get down to the degrees at the end, and I'm good. Okay, 11. A central angle of radian measure theta intercepts an arc length s on a circle with radius r. Okay? Arc length. Formula's up.
Wait, alright. How do you change it from the decimal to a fraction?
Math, enter. Okay? So here, depending on what values you get, we're just going to do a little algebra with it. So here it says, find s, find the arc length, if the radius is 8, and theta is pi over 4. Okay. Now, my pi doesn't cancel this time, but I still want to reduce the fraction as far as I can. So I still do 8 over 4. And if I need the math enter, I can, but I really don't need it here. And I get my answer. But be careful, I may not just give you r and theta every time. For example, letter B. Find theta. Ooh. If s equals 27 and r equals 9. That's still not a bad deal. What's my one step to figure out what theta is?
Yeah, you just divide by 9.
Just divide by 9. No worries. Like, okay. This isn't the worst thing ever. We're making some progress here. Like those. Okay. Oh boy. All right. Special rights. Reminder, and I'll put them up here at the top, but again, they're on the help. So my 45, 45, 90. Both of my legs are x. My hypotenuse I just multiply by the square root of 2. For my 30, 60, 90, my short leg, the one that's opposite from 30, opposite from the smallest angle, is x. My long leg, the opposite of 60, is x square root of 3. And my hypotenuse is 2x. But again, you don't have to have that memorized because it's going to be up and available for you. So when I get down to these, I basically, this is just me, normally what I'll do is, if I see what type it is, I'm like, ooh, this is a 45, 45, 90, is I just make little marks around the edges to remind me what everything is, so I understand what the format is. Then I go looking for the side where there's a value, okay, right here. So here's my job. those two things have to be equal. So 5 has to equal x times the square root of 2. Okay. So to get x alone, got to do a little algebra work here. I wipe that out, but then I notice a problem. What's my problem? Yeah, I can't have that radical down there. I got to fix that. Now, we've talked about a pattern before. We'll bring that up again in a minute. But I can fix the problem pretty easily by just multiplying the numerator and denominator by that square root. So notice I didn't multiply the 5 and 2. The 5's not under the radical. The 2 is. These two guys, when I multiply them together, I get the square root of 4, which is 2. Okay, that's my, air quotes, x value. So both of these values are just x. They're both going to be 5 square root of 2 over 2. But we talked before about if I see that situation and I remember it, I'm just taking half of this value times the square root of 2. Half of 5 is 5 halves. If it was a better whole number like 6 or 8 or 10, I'd just take that number, divide it by 2, put a square root of 2 on it, and that'd be good. But that's how I can tackle these. And that problem right there is about as bad as it gets as far as having to do math work on it. The rest of them will not necessarily be that bad. For instance, number 2, not going to be that bad. Because I'm like, okay, so 45, leg, hypotenuse. But this time life is easy. You're like, why do you say life is easy? Because when I look where my value is, x times the square root of 2 equals 6 times the square root of 2. Oh, what's x going to be? Square root of 2 is cancel. X is 6. No radical to have to play with this time. So this is 6. This is 6. I'm done. Now fast. Not a bad deal. Not a bad deal at all. All right, let's see if this next one works that way. We're on a 45, 45, 90 roll here. So x square root of 2. Okay, so my x is 2 times the square root of 2. Okay, so that makes this one easy because it's always going to be, the two legs are always the same. Now this last part's where I got to be a little bit careful. If that's my x value, ooh, I don't even have to do that. I'm just going to plug this in where x is at. So I've got 2 square root of 2, but I already have a square root of 2 here. Because if this is the x value, this just goes there. And then I'm like, well, what's that going to be? Multiply what's underneath the radicals together. So 2 times 2 gives me the square root of 4, but I know what that is. The square root of 4 is just 2. So that is going to be just plain old 4. So the hypotenuse is the normal number this time. But again, it's just being patient, taking your time and plugging values in as you go. So now, we finally make it to our 30, 60, 90s here. So I get my angles in, and then again, I'm going to label. Across from the 30 is x. Across from the 60 is x square root of 3. My hypotenuse is going to be 2x. So I'm going to look, I'm going to say, okay, what do I have and what does that tell me? I got these guys. So x square root of 3 equals 2 times the square root of 3. And again, I basically can look at that and know that x is going to be 2. Because if I try to solve, it just cancels them out of there. So if x equals 2, that tells me my short side, or my short leg. And then everywhere else I see x, I just replace it with 2. So over here, okay, 2 square root of 3, I already got that part, and don't have to do that. And then this is just going to be 2 times 2, which is 4. Again, don't make life harder than you have to. Keep it simple, keep it simple. So as we kind of keep plugging away here, okay, get my 30 in there. So I got my x, my x square root of 3, and my 2x, and I go to work doing my algebra part. So I look and I'm like, okay, so here I notice 2x equals 10, divide by 2, x equals 5. So what's that mean? The side that's just x is 5, and the side that's x times the square root of 3 is 5 times the square root of 3. So a tiny bit of algebra, a little bit of substitution, and we're off and running. Yes. And so then there's one more here. So we'll label our sides. Now this one, it's going to get a little more challenging again. Because I'm like, okay, so 2 equals x square root of 3. But I need x alone. So I got to divide by the square root of 3. But unfortunately, the square root of 3 does not cancel on the other side. So I'm going to have to fix this. I'm going to have to rationalize it. So I'm like, okay, so this time I take care of that with the square root of 3. And I get my x value, kind of funky looking. Fraction and a radical. So this side will be 2 square root of 3 over 3. It's my x. And then 2x just means you multiply the value outside here by 2. So 2 times 2 would be 4 square root of 3 over 3. And we're set. So again, that's not terrible, especially when you're going to have the right triangles available to you. So that should make life a little easier. Okay, so the last one. Well, last ones, I guess I should say. Okay, what's the measure of the angle? Use your trig. So I look, I'm like, okay, oh yeah, I remember these two. Got this line, got this dot. We're always going to form a triangle back to the x-axis. And once we do that, my job is to figure out what type of triangle this is. So I got this coordinate, this x and y value, and so I'm going to label the sides that I know by this. Okay, here's my x-axis. It says the x-axis value is -3, so I put that on the x side. My axis going up and down is my y. It says my y value is -3. So I start to look at this, and I'm like, which type of triangle has the two sides that are the same? 45, 45, 90 has two sides that are the same. So that tells me what those two angles are. Okay, that's not a bad deal. Well, not quite. Okay, because the angle, remember, I've got to know what all of this is. Now, I don't need my protractor. Don't do the protractor. Silly. So I think about it, and I'm like, okay, so if I was starting to count around here, from here to here is 180, but I have another 45 from my triangle. So 180 plus 45. And it went counterclockwise, so it's positive, so it's 225 degrees. But notice again, and the directions on the quiz will be the same tomorrow, use your trig. If you just bust out this guy and try to measure it, that's not all of, you won't get all the points. I'll just put it that way.
What if you get the right answer?
You would get the point for the right answer, but you would lose the point values for not having used the trig to do it. So I'm giving fair warning. So, okay. Draw back to the x-axis. We're going to do the same thing. The x value, so on the x-axis is -2 square root of 3. My y value, I really placed that poorly, is going to be 2. So again, I ask myself, which triangle has a side that has a square root of 3 with it? Duh, 30, 60, 90. Okay. So when I go to label here, okay, the side without the square root of 3, okay, so that tells me this is my 30, and this is my 60. And so now I notice, I'm looking this time, I'm like, okay, let's see. Ooh, it's going clockwise. So as I'm counting around, I'm like, oh yeah, it's negative. So to here it's negative 180, add another 30 to it. So negative 180 and negative 30 gives me a negative 210. So, again, this is what you've got to deal with tomorrow. The help will be up there. Okay, have your protractor. If you need an extra one, they'll be in front of the folders. But work through these. Again, look at some of your sheets. If maybe there's some of the homework problems that you hadn't done because you didn't get something and now you do. Do those to reinforce it. But again, you've got to reinforce the learning or it just disappears. Okay? So let me get this.